Hello students, welcome to the online tutorial session. Today we will learn about the various type of networks, about the terminology and different type of transmission method. Okay, so earlier till date we have learned about the distance based network classification, that is different LAN, about the LAN, MAN or these things. And the topology based network classification we have also learned. Bus topology ring we have completed. But today with the first topic for this session is, that is communication based network classification is there, and another the terminology. Okay, so first we will learn about the different terminology. Okay, so this the first one is, that is bandwidth. Okay, so what is actually the bandwidth? If you are able to see the picture, okay, then so bandwidth of a channel indicates the range of frequency that a communication channel can handle with a reasonable reliability. Reliability means that how actually the product, or you can say service, you can trust on. Suppose if you're working with a software, so if you're giving input 100 times, so it will give you the result 100 times true, then you can rely on it. Or it will give you 99% times output correct, then you can rely on. Otherwise you cannot rely. It is not a reliability. So that is the reliability. Okay, so how we can do it, or you can treat the bandwidth as a physical property of the transmission media. It is actually the difference between the Fmax minus Fmin. Fmax is the actually the highest frequency and Fmin is the lowest frequency. Okay, so difference between highest frequency range and the lowest frequency range, or maximum frequency or the minimum frequency. Okay, so this can be measured in terms of hertz. Okay, so in case of the majority frequency in the human voice lies in the range of 400 to 3400 hertz. Okay, maybe my mine one is more than 3400 hertz. Okay, jokes apart. Now so why actually we need to learn this bandwidth terminology? So the rate of transmission of the data is directly proportional to the bandwidth of the channel. So more the bandwidth, more the data carrying capacity. So okay, if the bandwidth is very big, or okay, so range is very big, then it can carry the data smoothly. Okay, now coming to the next one, that is the signal to noise ratio, or you can say it is SNR. Okay, it allows the signals to be transmitted over a long distance with a sufficient degree of accuracy. Okay, so actually it is easier, actually larger actually frequency, it will help us so that we can detect the frequencies from the receiver, and it will be easier to detect. Okay, now what is the channel capacity? So channel capacity of a channel indicates the maximum number of binary digits that can be transmitted through this noisy communication channel per second with minimum error. Okay, so it is measured in the bit per second, or you can say that BPS. Okay, now coming to the baud rate. Okay, so what is baud rate? Baud rate of a channel indicates the signaling speed of a channel, that is the number of data signal symbols or the signal transmitted by the channel per second. That is the in case of capacity, don't mix it with the this term. Okay, channel capacity is a maximum number of digits. Okay, and here is the number of data symbols or the signals, okay, transmit per second. So how can we differentiate between the bandwidth and the baud rate then? Okay, so bandwidth, the concept is usually used in the telecommunication theory to indicate the range of frequency that can be transmitted through a particular channel. And the baud rate, the concept is indicate the signaling speed of a digital communication. Okay, communication line. Okay, in case of bandwidth, the channel whose bandwidth is B can transmit at the rate of B bits per second. B means take as B, there will be number. Okay, and N baud lines transmit at a rate of N symbols per second. Okay, now third point, in case of digital communication, it indicates the maximum number of bits can be transferred through a channel per second, and in case of digital communication, baud rate means the number of times the signals can change its value per second. Okay, it is measured in hertz or beats per second, and it is measured the symbol per second, where each symbol can be encoded more than one beat. So now coming to the next topic, that one is known as the communication based network classification. Okay, under this communication based classification, there are two type of network is available. One is point to point, another one is multi-point. Okay, communication. So first we will read about the multi-point, and then we will be moving forward to point to point. Okay, so this point to multi-point network is also called a multi-point network. So point to multi-point or normally multi-point, both are the same. Okay, so in such a network, data is transferred from one signal location or a node to the multiple location. As you can see, there is a base station is there. In the picture you are able to see one base station is there. See this one. Okay, and 1, 2, 3, 4, the radio cars or sector antennas are there. Okay, so it is transmitting to the all four. Okay, from one source to the several destinations. Okay, so via a different path. It is not that they are actually transmitting the signals on a similar path. No, they are following the different paths. So this is actually mainly used for the wireless communication, where the central antenna broadcasts the data to the several sources. Okay, transmitting the signals using the wireless modem. Okay, so this is the point to multi-point. Okay, now coming to the point-to-point connection or P2P connection. Okay, so in such network, the communication takes place between two endpoints. Okay, here multiple stations are not involved. Okay, data is transferred by one computer and received by another computer only. Okay, so see here over here. Okay, amber crystal radio with the integrated antenna, and here is another one. Okay, radio antenna with the integrated antenna, here is another one. Okay, so only two devices is involved over here, and transmissions can happen between these two only. Okay, so the communication can be both ways, but in signal direction. A can transmit to B, B can transmit to A, but in a single direction, not in a both ways direction. Okay, so the two distance computer can also be connected using the lease line or the modem to form the point-to-point network. Okay, so now we will differentiate between these two. So first is link. Okay, so this is dedicated link between two devices in case of point-to-point. In case of multi-point, there is a link shared between more than two devices. Okay, channel capacity, that we have learned this term channel capacity in this lecture. The channel's entire capacity is reserved for two connected devices, but here the channel capacity is shared temporarily among all the connected devices. Transmitter and the receiver, here the single transmitter and single receiver is there, but here the single transmitter is there but multiple receiver is there. Example, you can say frame relay, T-carrier, or frame relay, token ring, Ethernet. Okay, these are the examples. Now coming to the different transmission methods. Okay, previously we learned about this transmission, half nuclear, simplest. Don't get confused over these two terms. Okay, there is also a transmission, here is also one transmission method. Okay, so that one is actually the communication mode, okay, and this one is the transmission method. Okay, now this is the first one is serial transmission. Okay, so in this type of communication, information is sent one bit at a time serially through a single communication cable. Okay, so suppose a 8-bit information is there. See over here, 0 1 0 0 0 1 1 0. Okay, it is there. So what are we going to do? So the 0 1 1 1 1 0 1 like this there. So what we're going to do? We have to transfer each bit, first 0, then 1, then 1, then 1 single bit at a time. Okay, so a serial mouse is such a device where the data from the mouse is transmitted to the computer through a serial cable. Okay, so what are the advantage you are getting over here? Since the signal cables can be used for serial communication, the cost of a setting up of serial communication is lesser. Okay, computing overhead also less, but disadvantage is what? That the computer data for parallelly, hence the data flow needs to be converted into parallel to serial and vice versa. So we have to conversion need to be there. Okay, so in case of parallel transmission, what is going on? So in this type of communication, multiple bits are sent at a given time. Suppose a 8-bit information is there. In a one shot, you can transmit it parallelly. Okay, so that's it like this: 0, 1, every bit is going. Every bit is going in a one way. Okay, at a given time, all bits can be transferred through a parallel communication lines, with each line carrying a single bit. Therefore, the data transfer rate of a parallel communication is higher than the serial communication. Advantages: what? The number of bits transmitted per second can be more than the serial communication. Disadvantage is what? Since the multiple lines are required to be transmitted, the cost of parallel transmission will be higher. So as we have learned what is serial communication and what is parallel transmission, now we try to differentiate between these two. Okay, so in serial transmission, data it means bit, that is digit, flows in bidirectional. Okay, and in case of parallelization, data flow in multiple lines. Okay, number 2, in serial transmission, cost is actually efficient, but it's not efficient because it's high. Number 3, 1 bit transferred in a 1 clock pulse, but here 8 bit is transferred at a 1 clock pulse in case of parallel. In case of serial transmission, it's a slow comparison to parallel, and comparison to serial, parallel transmission is fast. Okay, but serial transmission is used for the longer distance, and the parallel communication is used for the shorter distance. Okay, so circuit for the simple transmission, that side is simple, but in case of parallel transmission, it is a relatively complicated. Okay.